Hi. How's everyone? George Washington, the cherry tree, and Newton's second law. What's the connection? Well, we all know about George Washington and the cherry tree, and his father said, "Did you chop down the cherry tree?" And George Washington said, "Absolutely." However, little known fact. By the way, Judine, do you know what number president of the United States George Washington was?
Number 1.
Number 1, excellent. The father of our country, excellent. Now, he kept a journal, and he kept a lot of data in the journal about this cherry tree. He did. And he said this, that the axe head was 2.5 kilograms, that the velocity he swung that was 25 meters per second. That's pretty fast. 2.5 kilograms, pretty significant. That's like 5 pounds. That's like a 5-pound bag of sugar. He goes into the tree. He goes in 2.3 centimeters. See right here? So he hits it 2.3 centimeters into the tree, or 0.023 meters. Remember, we only use meters, right? We use meters, seconds, and kilograms. Right? Okay, good. Excellent. Now, let's look at a couple of equations. We know Newton's second law of motion is F equals ma. It's right here. We're given information about the axe being swung. We're given velocity and distance. What function relates velocity and distance? V of d. Vf squared equals V naught squared plus 2ad. Final velocity, initial velocity, acceleration, and distance. Okay. Rearrange that for A because I want to put that in for A. Yeah? Now, that's the rearrangement. Ruminate on that for a second. You see that? I subtracted V naught from both sides. Then I divided both sides by 2D. Make sense? Yeah?
Yeah.
Now, I'm going to take that and I'm going to plug in here. I'm going to plug in for A, and this is what I get right there. That make sense? Mm-hmm. I'm going to erase the board, and why don't you guys kind of look at that? Think about that for a minute, okay? Look at the data, and look at that, okay? And I'll erase this here. I'm not going to erase the tree. I like the tree. Okay, now, here we go. You ready? Okay. F equals 2.5. I'm leaving off the unit labels because it looks neater.
Yeah.
As long as we're using meters, kilograms, and seconds, we're cool, right?
Okay.
Okay, good. Now, this is going to be 0 minus 25 squared over 2 times 0.023. Easy? Now, 25 squared is?
625.
Yes, you know your 25 times tables. Excellent. Excellent, Judine. Excellent. Now, but it's negative. That negative is not squared, is it?
No.
No. Tricky. Yeah.
Yeah.
So that's going to be negative 625 over 0.046 times 2.5. I know that this, right, what's this equal? What's that equal? Judine?
13,586.
Excellent. Excellent. Right? Make sense?
Yeah.
Now, we know. Make sense? You see that? Okay? Yeah? You okay? So we know that this is going to equal F equals negative 34,000 newtons. A newton is kilogram meter per second squared, right?
Yep.
Newton.
Yeah.
Not Fig Newton. I know you're hungry. I know it's near lunch, but it's not Fig Newton. It's after Sir Isaac Newton. The question is, what are Fig Newtons named after? I don't know. Let's look that up. Okay, so this is going to be the force that was used to hit the tree and drive that X in 2.3 centimeters. Yeah? Good? Now, what force did the tree use to stop the X? That's important. Newton's second law, Newton's third law. For every action, there's an equal and opposite reaction. Equal and opposite. I walk. I press down on the floor. The floor presses up on me, right?
Yeah.
So, it would be, this is the X, and this is the tree. Would equal positive 34,000 newtons. Okay? Easy?
Yeah.
So, negative 34,000 newtons, X. Positive 34,000 newtons, tree. Easy?
Yep.
Okay, who was the second president of the United States?
Adams.
Yeah, excellent, John. John Adams. Excellent. Okay, thank you very much.